Okay, in this last one, we're going to do the opposite or reverse or mathematically the inverse. And that should help you remember the command we're about to learn. This one's not done as much. Usually we have a z-score and we want to find area. And this time we have area and we want to find a z-score. So we're doing the opposite. So for instance, what z-score has an area to its left of 0.793939. Same strategy as before. You should draw a picture, sketch out that curve, mark off the point of interest. That's going to be, what is this going to be? Area to the left. So right here, the area to the left of this is 0.5. So it's going to be somewhere over to the right of 0. We don't actually know. We didn't really know for sure it was going to be less than 1. So you maybe didn't need to put these numbers on the bottom because it kind of adds confusion on this one. But we mark this, and what we're wondering is what z-score exists such that the area to the left is 0.7939. The z-tables makes this pretty easy if it's on it. So you're working backwards. So you would find your area to the left inside the table and then figure out the z-score was 0.82. And we're done. Oops. So 0.82 is the z-score. The calculator has a thing called the inverse norm. So that's in the same distribution menu that we've been using. It's right below the normal CDF that we've been using. The opposite is the inverse norm that's right below it. This is when we're going backwards. And this is a little bit frustrating on new calculators. You actually have an option to put in the tail. On older ones, like the emulator I'm using, you do not. And so on these older ones, the area that you're about to put in is always the area to the left. Always area to the left. Just like the z-score. They built the calculator to mimic sort of using a z-table. So area that you feed in here is a left tail. We call it a tail. Let's see, where were we on the slides? So we want the area left. That's why we did a picture. This is the area to the left of our magic z-score. So that's what we put in. And you put it in as a decimal number, not a percent. So here's the example, our area to the left, and we're doing it's a z-score, so we put 0 and 1 as the mean and standard deviation. So that is my z-score. How would I know that for sure? I could do the other way. So, okay, so what is that saying actually? That's saying this value of z right here, we're claiming it's 0.82, this z-score right here. So we could double check it by going back through the area and put negative infinity as the left. And I forgot what it was. That's why you write things down. That's what we think the z-score is, 0.82. Yeah, oh, okay, I didn't forget. Let's do this again. It's positive. So we're finding the area between negative infinity and 0.82 right here. So now this is the area, and that matches the area. So this second step was just a verification that it was right. You don't do this a whole lot, this inverse process, so I think that's the only example. Yeah, okay. There is a whole other lesson coming up on using the normal distribution on actual data instead of just the z-scores. So that's what's coming later. See you in that one.